My name is Carlos Bartesaghi. I am a research fellow at the Faculty of Built Environment, UNSW. Well, I am an architect by profession, that's my profession, but after I finished my bachelor degree in architecture, I just took several courses in sustainable design and sustainable infrastructure and back in my country in Peru, but also went abroad, attended different conferences, and then after that I decided to pursue a master here at UNSW. So I got a master in sustainable development, and after that I just started my PhD, who just finished. So it's PhD in built environment as well, with a special focus on remote sensing, urban forestry and urban climatology. My PhD, it was a very ambitious project, in fact, and I focused on different aspects, but the most important was assessing the thermal performance of urban vegetation, and for that I just use different methods. One of those is using airborne remote sensing, which is the retrieving images or using images collected by aircrafts, and those images are thermal images and spectral images, so give you a signature of the quality, can give you an idea of what is the quality of different surfaces, and then try to correlate the different temperatures of a given place of the study area with the amount or proportion and distribution of trees. The idea is, like, we don't have enough guidelines right now, urban designers, practitioners, policymakers, in order to know what is the correct amount, proportion, distribution of greenery that are more effective in reducing land surface temperatures. So I use these images to have an idea, to use empirical data in order to determine which is the right proportion of trees we need. Green infrastructure was the key focus of my research. Green infrastructure in this case is defined, or it was defined in my PhD thesis, as all the natural and artificial elements that are available in the built environment that can provide ecosystem services, different sort of benefits to human beings and other creatures or and beings in the built environment. Well, generally, the urban heat island is it's a phenomenon in which the temperatures of urban areas are much higher than the temperatures in the rural areas. But this is a concept that has been changing over time, because now we have different types of urban heat islands. One of those is surface urban heat island, and the other is canopy layer urban heat island, among many others, but those are the two most important. So surface urban heat island refers to the difference in the temperatures among different surfaces in urban areas and rural areas, or vegetated areas and built areas. But the canopy layer urban heat island refers to the air temperatures. So it's good to do this discrimination because both phenomena are interrelated in some way, but at the same time are triggered by different sort of phenomena or issues, and it's related to different aspects in the built environment. It's critical because the way we are designing and building our cities now does not consider the integration of as I said before, of vegetation. The more buildings, the more pavements we are putting in the cities, the higher the temperatures, and that situation is threatening the health and the well-being of people who inhabit those places. So when we design, it's really important to consider living architecture and other elements, including the space in between buildings, the location of the trees, and the different qualities of the materials we are integrating in our designs, because that will affect definitely human beings who will inhabit and will use the urban spaces. Green roofs and green walls, or living walls as well, they are part of the green infrastructure network. Not only trees and green open spaces are part of it. So during the time that I was just conducting this research, I found different points of view. So I think the most important one is just to try to integrate them, both green roofs and vertical greenery systems, to what are the existing urban green infrastructure networks. But currently has not been done properly. I think still in the way we are designing, we consider them separately from what it is a purely natural feature in the built environment. I think they should be completely integrated to buildings and integrated to the landscape, to the urban landscape. They are key in reducing reducing urban temperatures, especially of roofs, but at the same time they have a lot of benefits in indoor thermal quality that we should also consider as part of our designs. I think living architecture, specifically what is taught in this course, are just topics that are vital in your practice, in your daily life. I think whatever you can learn from this course will be definitely applied and will definitely produce some benefits in the users. So not neglecting greenery or vegetation. It's something that is typically done in many of our architecture schools, or when we are learning. We put a lot of attention on how it is the form, how it is the aspect and the function of the building itself. But we forget how that building will be integrated in the built and the natural environment and the effects that will carry. So in this course, you can have the option and the capacity to explore those topics and try to really integrate nature in your designs, and so you will have better solutions in the future that can really have potential benefits in human beings and other species as well.